do we use scientific notation? So the first thing you want to talk about is there's two real big things you want to understand. What is scientific notation? That's when you're writing either really large or really small numbers by multiplying by a power to 10. Sometimes that power of 10 is a positive power. That means you're doing a really large number. And sometimes that's a negative power. And the key thing to remember in scientific notation is that this term that's being multiplied by the power of the 10 is always going to be greater than or equal to 1, but less than 10. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, or 9, or some kind of decimal in there. And that is called the mantissa. That's the other new word. Mantissa, scientific notation. The two big vocabulary words here that I'm going to talk about in this video. So this first example has this really, really large number, and it's writing it in scientific notation. So when I look at this, that number is not between 1 and 10. So since it's not, I have to move the decimal point. And I moved it over 8 spots to the left. And since this is large, and 8 to the left means we're going to have a positive exponent under 10. So my mantissa became 1.5. That is greater than 1 and less than 10 times 10 to the 8th. And the 8th came from the number of spots I moved the decimal point. And again, that's positive 8. Down here I have a really small number. So I moved my decimal point to the right. I moved it 6 spots to the right, making my exponent 6, but in this time it's negative 6. And my mantissa became 7.45, so 7.45 times 10 to the negative 6. Again, your mantissa is that number, it gets multiplied by the power of 10, and this whole term is in scientific notation if your mantissa is 1 or higher, but less than 10. So, here's some things we can do. We want to compare numbers in scientific notation. So for example, I have 3.25 times 10 to the negative third and 4.1 times 10 to the negative fourth. What I had to do is I had to move the decimal point because to compare, you always want your powers of 10 to be the same. So I moved my decimal point 1 to the right. And when I go to the right, I add a negative 1 to the exponent. So it became from negative 3 to negative 4. So now I have 10 to the negative 4. But this is 32.5 and this is 4.1. And 32.5 is greater than 4.1. So I would say that 32.5 times 10 to the negative 4 is greater than 4.1 times 10 to the negative 4. So we would say that this number, going back to the original problem, is greater than the other one. Next, I would want to, when I'm comparing numbers, a lot of times they'll ask you how many times larger is one number than the other. So in scientific notation, say I have 2.9 times 10 to the 7th and 1.06 times 10 to the 6th. I can compare them by looking at these two numbers and saying this is about 1, this is about 3. It'll usually ask about, so I don't need an exact, but 1 times 3 is going to equal 3. So this number is 3 times larger. And the exponents is 10 to the 1 times larger because it goes from 10 to the 6th, 10 to the 7th, so it's 10 to the 1st. So it's 3 times 10 to the 1st times larger. 3 times 10 to the 1st times larger, or about 30 times larger. This number is about 30 times larger than that number. Now, not quite finished because I want to talk about adding and subtracting. So I can add and subtract numbers in scientific notation. You would add them by, you first want to make sure you have the same exponent. So you got to make sure that your power of 10 is the same to both add and subtract. In this case, it is. So then you just add your mantissas, 3.5 plus 6.1, 9.6 times 10 to the 7th. In this subtraction problem, I made it so that way the powers of 10 are different. So I had to adjust one of them, and I adjusted to 4.2. I moved it 1 to the left, which adds a power of 10. So it becomes 0.42 times 10 to the 5th. Then I do 2.53 times 10 to the 5th minus 0.42 times 10 to the 5th. I end up with 2.11 because I just subtract the mantissas. 2.53 minus 0.42 equals 2.11. My exponent is 10 to the 5th, and I can keep this the same because my mantissa is still between 1 and 10. And then the next one is multiplying and dividing. These are also kind of similar. You got to remember your multiplication and division rules for exponents. So here I have 2.1 times 10 to the negative 4th times 3.2 times 10 to the negative 6th. In this case, you just use the commutative property of multiplication or the associative property to regroup this. So I do 2.1 times 3.2 to get 6.72. And then I multiply my two powers of 10 together. And when you multiply, you just add the exponents. So negative 4 plus negative 6 is negative 10. So it's 6.72 times 10 to the negative 10. With the division, I recommend you write it like a fraction. So instead of doing 1.6 times 10 to the 5th divided by 6.4 times 10 to the second, I put them on top of each other like this. And so then I'm lined up and I can just divide my mantisas. 1.6 divided by 6.4 is 0.25. And 10 to the 5th divided by 10 to the second, I just subtract my exponents and I get 10 to the 3rd. Now this mantissa is less than 1, so I have to adjust it by moving 1 to the left. And when I move my decimal point, or 1 to the right, I move my decimal point 1 to the right to get 2.5. And when I move 1 to the right, I add in a negative, I take away 1 from the exponent, so it becomes 2.5 times 10 squared. And that would be how you divide. And again, we're all the way back to how do we use scientific notation.